Yo, what's going on, guys? It's Inertia back with another video, and in today's video we're showing you how to make a Roblox ESP. Let's go ahead and jump right into it. Alright, so getting started here, we're going to hop into Visual Studio and we're going to go ahead and start coding. So we're going to start by defining some variables. So local players equals game colon get service players. Then we're going to define the run service. So local run service equals game colon get service run service. Then we're going to define the camera. So local camera equals game dot workspace dot current camera. So basically, players getting the player service. This handles everything to do with players. Run service, this will be for our loops. Camera for our measurements, like scaling and stuff like that. Next, we're going to add one table, call it ESP. It's just going to be a blank table. This will hold all of our elements. So next, we're going to create a function for when players join the game. So we're going to do local function, add, and then player parameter, and then down end. We will come back to this. We're going to add a couple more functions. So next we're going to do local function remove with a player element down end, and then we're going to add a loop where for underscore comma player in players colon get players do, and then we're going to do add player. So okay, so basically what this is doing is for when we first execute the script, it's going through all the players that are currently in the game, and it's going to add them to our ESP table and do the drawings and stuff like that. All right, now we're going to fill in the code for the add. So we're going to do if player equals players dot local player, then end, and we're going to just return. So basically this loop is making sure that the player that we're adding is not ourselves, because we don't want to draw ourselves, and then it's just ending the loop. All right, next we're going to do ESP, referencing the table, then we're going to do player entry, and then we're going to add a table inside this entry. So basically what this is doing is it's adding a player entry to this table, and then the value for that player will be a table with the drawing. So first we're going to pass the parameter of characters. We're going to do character equals player.character. Then we're going to do box. Oh, make sure you add a comma between these elements. So we're going to do box equals drawing dot new, and then we're going to do square. Then we're going to do one more, copy this, paste it. We're going to do box outline. All right, next we're going to do player dot character added colon connect function with a character parameter end. Then we're going to do reference ESP table. We're going to do player dot character equals character. So basically this makes sure that the character is always assigned. So sometimes the player will be added before the character is loaded, and that will cause errors in the script. So we're just double checking to make sure the character is always added. Next, we're going to do player.character removing colon connect function with no parameters end. Then we're going to do ESP with the player parameter. Then we're going to do dot character equals nil. So basically we don't want to draw on an old character, so when the character is removed we basically nil it in the table. All right, next for the remove function, all we have to do is do local data equals ESP player, and then we're going to do if not data then return end, and then we're going to do data dot box colon remove, and then data dot box outline colon remove, and then we're going to do ESP player equals nil. Okay, so that was a lot, so we're going to go back and make sure that you guys understand this. So for the add function, wherever we call this, we're going to pass a player. We're going to make sure it's not our local player. Then we're going to create an ESP table, or we're going to create an entry into the ESP table with the player, with the character, a box, and a box outline. So now we can, when we reference the ESP table, we can put in a player's username and we'll get their certain drawings. Then we're adding sanity checks here for the character. Pretty simple stuff. Now for the remove function, we are getting the data of the player, we are making sure it's valid, and then we're removing the elements inside and nilling the player entry. So whenever players leave the game, we'll call this function so we can get rid of them, and this will save memory. Now we're going to do a players.playerAdded connect add, and then players.player removing connect remove. So basically what this is doing is when a player is added, it's going to call the add function with the player parameter, and then when the player is removing, it's going to call the remove function with the player parameter already inserted. All right, next we're going to do the actual ESP drawing. So we're going to create a run service loop, run service.rendered stepped connect function with no parameters for now. Now we're going to do a for loop, so we're going to do for player data in pairs ESP do. Okay, next, now we're going to do local character equals data dot character. If not character, then continue. And okay, continue is basically, since this is inside of a loop, you want to use continue as it's better practice. So it's basically the exact same thing as calling return, but since we're in a loop, we're going to do continue. So next we're going to do local root equals character find first child humanoid root part. Then we're going to do if not root, then continue, not content for face, continue, end. Then we're going to do local pause comma visible. So basically this is setting two variables. So the function we're about to call it returns two values. So we assign two names to this variable. So we're going to do camera, not can render weapon, camera world to viewport point. We're going to call root.position. So basically what this does is it gets the screen position of the root position. So the root.position, this is a vector 3, this returns a vector 2 and a visible or not property, which is why we assign 2. Next, we're going to add our scaling math. I will provide this in the description, as I'm not going to type all this out right now. So you can just go to the description and copy this. This is all you'll need for scaling. All right, next we're going to do if visible, then else. And so basically what we're doing is if the player is visible on screen, we're going to display the drawings. If they're not, then we're going to hide them. So we're going to add in the else, we're going to do data.box.visible. Visible, if I could type, visible equals false, then data.boxOutline.visible equals false. If I could type, equals false. All right, now we're going to do our actual work here. So we're going to do data.box.position equals vector2 .new x position and y position, then data.box.size equals vector2 .new. Now we're going to do width comma height, and then we need to assign the outline position. So we'll do this and then just type outline and replace the name here. So now both of our boxes are positioned. Now we need to set colors and visible and thickness and all that, the fun properties. So now we're going to do data.box.visible equals true, and then we're going to do not texture does not equal texture equals true. And then we're going to do data.box.color equals color 3 .new 1,1,1. That's white. Then we'll copy this, paste it down here, change it to box outline, and change this color to whatever color you want, but I'm going to do black, so 0, 0, 0. Then we need to apply the Zindex, and the Zindex is the order in which the drawings will be drawn. if that makes sense. So for the first box, we wanted to draw over the top of the black outline so that it shows white and then black on the outside. So we're going to set this index to 2. So the higher this index, the earlier or the higher it'll be drawn. So we want to do the box outlines index to be 1. Next, we're going to set thickness. So we're going to do data.box.thickness equals 1, and then we're going to do data.boxoutline.thickness equals 2. And that is going to be it for our basic box ESP. So now let's go and jump in game and execute this. Okay, I'm in game now. I'm using Potassium. You can use whatever executor you want. This should work on every executor that has a drawing library. So let's go and execute. Boom, as you can see, we have basic box ESP. This works as if they go off screen, it hides them. It perfectly fits around the player, and it's not laggy. I'm not losing any FPS. Yeah, so this is basic box ESP. I'll be uploading part 2 tomorrow on how to add other features like names, health bars, etc. So yeah, if you watched all the way through, like, subscribe, and tune in for tomorrow's video. Peace out.